Hello, you are most welcome. I'm teacher Ivan from Wuna Educational Services. I welcome you to our last lesson concerning the change of subject of the formula. Please, if at all this is your first video in this topic, please go to our playlist, go to O-Level Mathematics. You'll find those videos, watch them so that we move together as we enjoy learning together. Otherwise, in this particular lesson, we are looking at how we change subject of the formula involving equations with fractional powers. So, we are told that, however, the variable to be made the subject is under the root. The root will be eliminated by squaring both sides of the equation. For the case of the square roots, or cubing both sides for the case of the cube root, or any other power will be handled accordingly. Let us look at examples. Example 1, we are given that A equals to the square root of A plus B, and they want us to make B the subject. But the B they want us to make the subject is under a root. The root is acting as a fence, meaning that for us to take away A so that we remain with B, we have to first break the fence. How are we breaking the fence? By squaring both sides. So, let us look at this in the solution. From the formula, which is the square root of A plus B, we shall first of all square both sides. Why are we squaring? Because we want to break the fence, which is the square root in this case, so that we are able to take away A and remain with B, which cannot be done if the square root is in place. That's why we are squaring. So the square reduces the square root. That is breaking the fence. So we end up with A squared equaling to A plus B. Now that the fence is taken away, we can take A the other side and remain with B. We want to make the subject. Hence, that gives us A squared minus A equaling to B, thereby getting B equaling to A squared minus A as our final formula after making B the subject. Let us look at other examples. In example 2, we are given that A equals to the square root of A squared plus B squared. So they want us to make small a the subject. But the small a squared is under a square root, which is acting as a fence, preventing us from taking away B squared so that we remain with A squared. And therefore, our first step is to break the fence, which is the square root. This one is broken by squaring both sides. So when we square A, we come up with A squared. On this side, the square will cancel with the square root, so that we end up with A squared equaling to A squared plus B squared. And since our major interest is to make small a the subject, we take this the other side. It is a positive, so on crossing the equal signs, it becomes negative, hence getting A squared minus B squared equaling to A squared. After that, we now introduce the square root to reduce the square, so that we end up with A equaling to the square root of A squared minus B squared. Remember, as we introduce the square root on this side, it should be also introduced on the other side. What is done on this side is also done on the other side, so that they are equally affected. So that gives us A as the square root of A squared minus B squared as our final answer. So let us look at example 3 concerning the same. Remember, we are looking at our last part of change of the subject, and in this particular moment we are looking at how we deal with the nonlinear equations having fractional powers. In example 3, we are given that A equals to P and the square root of Q over N. So they want us to make Q the subject, but the Q they want us to make the subject, one is under a square root, which is defending it from being made the subject. 2, it is also a fraction. So those are two cases to handle. It is under square root, so we have to first break the square root, and then it is also a fraction, whereby we have to eliminate the fraction. So let us look at how we do this. From the equation, which is A equaling to P into the square root of Q over N, first of all, since P is outside the square root, we first divide through by P, so that we get A over P equaling to the square root of Q over M. After that, we shall first of all square to eliminate the fraction, to eliminate the square root. But we are given a note that before squaring the term under the root, before squaring the term under the root, we square both sides, or we are going to square both sides. We square the whole term, that's what we are meaning. We square the whole term under the root and also the whole term this side. So we shall need the use of brackets then. We shall put the whole of this in bracket and square. We also put the whole of this in bracket and square. So that on this side, the square affects both the numerator and denominator. That is to end up with A squared over P squared. This side, the square root will be reduced with the square, so that we end up with Q over N. So on squaring, we shall have this, and after opening brackets, the A becomes squared and P becomes squared. Here the square root reduces with the square to end up with Q over N. But remember, our target is to make Q the subject. So after removing the fence, which is the square root, we now multiply through by N. So if we multiply by N, this N reduces with that, so that we remain with Q. And then this N multiplies A squared over P squared, so that we get Q equaling to A squared N over P squared as our final answer on that. Let us continue to look at more examples so that we master the content and get enough knowledge on how to deal with such fractional equations. This is one of the most crucial parts of mathematics. Otherwise, without this knowledge, you will find it hard to work out other problems in other topics. In example 4, we are given that P equals to R plus the square root of B minus, square root of A minus B. Once again, it is P equaling to R plus the square root of A minus B. They want us to make B the subject. So the B required to be made the subject is under a square root, which is acting as a fence, hindering us from making it the subject. Therefore, our first step is to break the fence by introducing a power. So we have R, which is already outside the fence. We first take the R on the other side to end up with P minus R equaling to the square root of A minus B. After that, we now square on both sides so that the square can reduce the square root. And we end up with P minus R squared equaling to A minus B. Since we want B as the subject of the formula, B crosses to come this side and it becomes a positive. Then this one crosses on the other side and it becomes a negative. So that we end up with B equaling to A minus C, the bracket of P minus R squared. So that is how we are making B the subject in this case. Otherwise, let us continue with the more examples concerning how we change the subject of nonlinear fractional equations. Example 5, we are given that P equals to 50 minus C, the square root of A plus B squared. They want us to make B the subject. So, as usual, the first step is we take what is outside the bracket, the other side. So that we take P on the other side, we take 50 on the other side so that we get P minus 50. But this one is remaining as negative and we can't deal with it when it's negative. We can't have a negative square root of a number. So there are two ways of doing this. One, we can take a 50 to the other side. Let us try it out here. We can take 50 to the other side so that we get P minus 50 equaling to negative square root of A plus B squared. But we can't have a negative square root. So what we do is we divide through by the negative. When we divide through by the negative, you realize that the negative divides the negative to become positive 50. And this one becomes negative P. So that we get negative P plus 50. And then this one also becomes a positive. So that we get positive square root of A plus B squared. So this one is the same as 50 minus P when 50 comes first. And it is the same. So here, to deal away with this, we just do this. Bring the whole of this with its negative on the other side so that it becomes positive. And then bring P on this side so that we end up with this. Hope the technique is simple. We bring this with the negative on this side to become positive. Then bring P on this side to become negative. That's done. After doing that, we now square on both sides. Remember, our aim is to make B the subject, but that B is under a square root, which can only be taken away by squaring. So the squaring will help us reduce the square root, so that we end up with A plus B squared. But as we are squaring, this has to be done on both sides. So after eliminating the square root, we now take A the other side so that we get B squared equaling to 50 minus p squared minus a. And since we are aiming at remaining with b, we shall get the square root to eliminate the square, so that we end up with b equaling to the square root of 50 minus p squared minus a. That is how we are handling such questions. Otherwise, I want us to look at our last example, and then we shall have some trial numbers at the end of this topic. Example 6 is our last example concerning the fractional powers. So, in example 6, we are given d as the square root of 4h over 5m squared, but they want us to make m the subject. So, how are we making m the subject? First of all, if you look at the equation, it is having two issues. One, it has a square root. Two, it is a fractional. So meaning that there are two steps here that we should think of. One is to eliminate the square root by squaring. After that, we shall multiply through by the denominator to change the fractional equation to linear equation. Let us look at how we do that. We are squaring in order to eliminate the root, but the squaring should be done on both sides. So that gives us d squared equaling to this squared. The square reduces with the square root, so that we end up with this. So this should be d squared equaling to 4h over 5m squared. But this is a fraction, meaning we must multiply through by the denominator to change from fraction to linear equation. So that gives us, when we multiply through by the denominator, we end up with 5m squared, d squared equaling to 4h. After, remember our aim is to make m the subject. So we are going to divide by 5d squared on both sides. So when you divide by 5d squared, that gives us m squared equaling to 4h over 5d squared. And then, since our aim is making m the subject, we are going to reduce the square by introducing square root on both sides. So when we introduce the square root, the root reduces, the square will remain with m, and on this side we shall have the square root of 4h over 5d squared. So that is how we shall handle such fractions. Otherwise, we are looking at how to change the subject of the formula. Yes, we still have more examples. This is example 7. In example 7, we are given t equaling to h, the square root of h plus w squared, b squared over 4, where we are supposed to make a b the subject. So in this, it is a bit technical. Reason being, we have two terms under the root, and out of these two terms, one is a whole number and the other one is a fraction. So how do we deal with this? One, since we are having a square root, the first step is to square both sides so that we can eliminate the square root. That is to say, when we square both sides, we get t squared, and then the square reduces the square root, so that we remain with the t squared equaling to h plus w squared b squared over 4. After that, since our aim is to make b the subject, we take h the other side. Since it is a positive, it crosses to become a minus. So we end up with t squared minus h equaling to w squared b squared over 4. Now, this gets us to a fractional equation, which we must change into a linear equation so that we can make what we want the subject. So we shall multiply through by 4 so that we change it to a linear equation. So, see, but these terms are both affected on multiplying, that's why we put them in brackets. We get 4 into t squared minus h equaling to w squared b squared. After that, we divide by w squared so that we get 4 into t squared minus h over over w squared equaling to b squared. And now we shall get the square root on both sides so that the square is reduced to b, and we end up with b equaling to 4, the square root of 4 over w squared into t squared minus h. So please, I want you to follow these steps one by one and do more trial numbers so that you perfect, because this is one of the most important topics in mathematics. Otherwise, we are going to close our topic with the last category of equations, that is equations involving logarithms. Please, I wouldn't love you to have you miss this because it is really important for us. Otherwise, see you in our next lesson. Bye bye.